Welcome back. Now that we've seen how a pointer is declared and assigned to a variable through the variable's address, and we've seen how to dereference a pointer to access indirectly or via the variable's address the actual content. Now, right here, what we're going to be doing is a deeper decomposition. So we will understand the anatomy of a pointer, specifically when it comes to how memory is being managed to support a pointer in C++. So I've broken down the next exercise that we're going to be doing together here into several sections based on these comments. So I've got two main sections. I have a preparation where we're going to declare a variable and quickly look at its content, inspect the content and the address for that variable. This second part is really the meat of this presentation, where we're going to declare and initialize a pointer to the variable we would have declared during the preparation phase. And then we will dereference the pointer and look at its content and what does a pointer really store, okay? All right, fantastic. So let's get started here. So the first thing I'm going to do is declare some sort of a variable that we will later on assign a pointer to it, okay? So how do we do that? Well, last time we used a variable of type integer. Nothing should stop you from using whatever data type you need and later on to make sure that you match it with a pointer of the same type. So let's say we have a float type, and this one specifically a double, okay, variable. And let's call it num. And let's go ahead now and assign num a value. Num equals 7.8 semicolon. All right, so now we've assigned it a value. Now we want to output the value stored in num and the address of num. So cout num equals num, and then we will also want to show %num is the address of this variable equals, and then put %num. Okay, so we can actually run the program at this stage just to verify and inspect how this variable behaves. So num has 7.8. The address of num is 22FF40 while this program is running. We're not guaranteed the next time we run this program to be assigned the same address. Okay? That is up to the operating system when it schedules this process. All right, so next, now we get into the declaration of a pointer. So you're going to need a double asterisk. So it has to be of the same type. Asterisk specifically says it's a pointer. Then you can call it whatever you want. I'm just simply going to call it PTR, lowercase. It still is a variable. Now I could leave it here and then assign the value later. But for this exercise, what I'm going to do now is also initialize it to %num. So right away, so this is different from the previous video's syntax. In this one, we not only declared it, but we initialized it right away. Okay, so now we would like to dereference this variable, okay, and look at what num or PTR is pointing at. So we would like to see what is the pointer All right, so let's do something like this. So let's go ahead and print PTR has this address stored in it. Okay? And what would that be? Simply show me what's in PTR. PTR. Notice I'm not using an asterisk, so I'm not dereferencing this. Okay? So this is simply going to show what's inside the pointer. All right. Next, we want to dereference the pointer. Star PTR has this or points to this value. And that would be star PTR. So this way, we will make sure that we understand the difference between a variable pointer with no asterisks and with the asterisk or the star. All right, well, let's look at this. Compile and run. And there you have it. So, num has this address. 022FF38. So what is the pointer pointing at? PTR has this address stored in it. So I'm missing an S there. It's fine. So guess what? That's the value, which happens to be an address, stored in PTR. When we use the asterisk, then that value leads us to where in memory we should pull out some information. And it happens to be 7.8 at that address. So that's what a pointer technically is supposed to do. Let me just fix this. Now, can we reassign a pointer to something else? Absolutely. Watch this. I'm going to go back here. I'm going to declare another variable, num2. Okay? And I'm going to assign num2 another value. Another value. So minus 33.2. How's that? Okay. Now, what I'm going to do here is reassign the pointer to another variable. So that's going to be really helpful in the future. By being able to reassign to another variable, you can see that the pointer is very flexible. All you have to do is assign it to another address, and it will extract the data that is referenced by that address. So how do we do that? Now, remember, I've already declared the pointer. So there is no need to say double asterisk PTR and num2. What you need to do is simply this. PTR already exists. You just need to assign it to the next variable. And notice now you're always assigned an address to a pointer. All right. So let's go ahead and I'm copying this. And we're going to do it again. See, what is it we're pointing at? Okay. And there you have it. And let's make sure that here we can also see num2 /n. And I'm just going to go over here. And I'm going to do this. Num2 has this value. And we would like to see also what is the address for num2. Okay, this is getting a little messy, but we can fix that. Here you go. And this is what happens when you do live code, okay? And we're going to do and num2. And let's end the program there. All right, so, or that line. All right, well, let's see how this behaves. Compile and run. And there you have it. So what do we have? We have num has 7.8 and it has an address 22FF38. Fantastic. How about num2? Num2 has minus 33.2, and it has a different address where the variable 33.2 is stored, right? Right here, okay? And then what is the pointer pointing at initially? Well, initially it's going to point to num, right? That's what we did. And then what happens after that? Then we moved it to num2. And as you can see, we can easily move a pointer from one variable to another by reassigning the addresses for these variables. Okay, and that's going to be a very important tool for us in the future when we reuse pointers. Let me see here. I'm just going to fix something here. I forgot to put an equal here just for the sake of making it look better. Recompile and run again, just to make sure everything looks good. There you go. All right, so just that equal was missing here. We're good to go. Excellent. All right, so stay tuned for the next video where we're going to learn more about pointers.